Welcome, this is Professor Bright, and we're going to go through determinants today out of Brecher 6.1. So this is our first experience with online learning. Be patient, and occasionally I'm having some tech issues. There might be a dialog box that opens up. Just ignore it, and I'm going to put it off to the side of the screen. But anyway, some best tips, best practices really to learn by video is first, I would recommend making sure to print out these slides. I know you might normally do this and bring it to class. Continue to do that practice, but print the slides, and then keep in mind these are videos, right? So you can do everything that you might do what you normally do with videos. And by that, I mean do what you normally do with videos, one thing at a time with videos. So that means pause me, rewind me, and in most cases, speed me up. Most students have told me, I watch you at double speed just because I can do that. If you want to, you certainly can. But keep in mind these videos are here. Take advantage of them as much as you can. So, without further ado, let's go ahead and dive in. Just as a reminder, I want you to warm up by computing these pseudo-determinants. Pause the video and try these out. Okay, well, the 2 by 2 is actually rather easy. We remember that it's the main diagonal product, so 4, and then minus the anti-diagonal, so 6. I get minus 2. For this second one, there might be some strategies that you might remember. You might remember doing cofactors. You might remember doing basket weave. I always remember basket weave with 3 by 3s. So when we do that, we get, let's see, 2, and then, let's see, that'll be 0, minus 1, and that's it. So I get a whopping 1 out of the whole thing. If you don't know basket weave, that's fine. You can get the same thing by cofactors, and actually cofactors is a better method in general. I digress. We'll review all that today. But before we get to determinants, we need to talk about invertibility. So because you might remember that when we were talking about inverse matrices, we brought up this idea of some conditions that we had to have. And having an inverse matrix really is closely connected, as you might remember, to a determinant of a matrix. So if we have an n by n matrix, we would say it's invertible if and only if the following conditions hold. There was something about the kernel. Okay, so if we call this matrix, let's give it a name A, right? We would say that kernel of A had to be the 0 vector only. Okay, and so consequently, if we were to look at the reduced row echelon form of A, we would get the identity matrix. Okay. Now, that was one condition that we could have for invertibility. Consequently, we could also say those conditions also mean that we have n linearly independent rows or columns in the matrix. Okay? And similarly, we would say that the matrix is invertible if the corresponding linear transformation, which is t of x is equal to ax, is invertible. Okay? And also, we would say that a matrix is invertible if and only if, the equation ax equals b vector has a unique solution for any b. Okay? And then, so that was kind of guaranteeing existence of an inverse, and now to actually find the inverse, we did this process before. We augmented with in, that is to say we have in matrix form, it would look like matrix A, and then on the right side we would have IN. And then we reduce row echelon, and then until we get IN, so it's going to look like IN on the left, and then A inverse pops out on the right. Okay, and then just keep in mind we have to have the linearly independent columns. Okay. All right, so then just as a quick check to end this video, which of these are invertible? Try it out and resume the video when you're ready. Okay, this one, the columns end up being linearly independent, so we do get that this one is invertible. Okay, and whereas the second one, if we look at the columns, we can say that, column 2 is 2 times column 1, so that is not linearly independent, so this one is not invertible. Okay, so we're going to pick up with this in the next video and talk about some more properties related to invertibility.